Hello friends of .NET. Long time no see. I was just streaming a few seconds ago, but apparently it doesn't work on YouTube. So I just restarted the stream in the hopes that this is actually working this time. So my name is Tidemon Landworth. You can still find me on YouTube. Yeah, I will hopefully have another episode today where we focus a little bit more on our compiler as opposed to debugging what's going on in our different streams. So I just checked YouTube. YouTube seems to work now, which is good. So we'll now close the window so we stop being distracted, and hopefully this is working better now. So today what I'm going to do is I want to focus a bit more on statements. So last time we had the ability to actually have statements in our language, and today I will add a few more constructs. I will add conditional operators that allows us to express ranges, and then we also have the ability to write if statements, for statements, and while statements. I'll also do a little bit of testing, because last time we had some issues with a few things that we didn't actually test error cases, and we did not do anything that involves some more complicated stuff, like, for example, detecting infinite loops in our parser. So we will hopefully fix that too. Then I would say, let's get going. So first things first, as always, let me check GitHub for PRs. So there is one here, I think. Let me check here what this one was. Yeah, this was the more interesting case, I guess. Oh, that's funny. What's happening here? I just want to switch the tab. Shouldn't be that hard. And yeah, so this is a redundant initialization. Because we basically just dispatch anyway to the next constructor, so this is actually a good change. And then let's merge this guy. And of course I can't spell Lex. Looks good for me, but hey, isn't that always the case? Good morning, Tyler. All right, so what do we have here? Yeah, this was the more interesting case where, so if we expand a little bit here, so we have our constructor, and in the constructor of the syntax tree, we now run the parser. The problem is that the reason I wrote this with a local variable before was these things are order dependent, right? So you can't really have parse compilation, you cannot really have diagnostics to immutable array before you call parse compilation unit, because you didn't actually go over the parse tree yet. Yeah, so the interesting thing here is that we probably want to figure out what's happening here. If we just delete this assignment here and just inline the local here, I'm not sure I like that from an ordering standpoint. So I'll probably go over this at some point later and like figure out what the correct response to this issue is. Meanwhile, I think we're ready to produce another branch for us. Episode, what is we today? Episode 7, right? Episode 7, 4, if, oh, sorry, let's do it the other way. If, for, while. Alrighty, so let me bring up my notes again, so I'm not forgetting anything. Yeah, so the first thing we should do is improve our ability to test. I know that we really want to do statements, but sometimes you have to finish the vegetables before you can actually do the fun stuff. So if we look in our tests here, we do have effectively positive tests, right? Where we basically say, here's a bunch of expressions that we expect, or statements, and what is the expected return value, right? Or the expected outcome. That's great for just testing that things work. It's not so great for testing that errors actually trigger, right? So for example, if I access a variable that's not declared yet, I would like to test that there is an error. The other thing I would like to do, though, is I would also like to test that the position where the error is reported is actually in some sensible spot and not, somewhere. Now, of course, I can hardcode the value and say, assert that this span is at, character 55 and, line 3 or something, but this just sucks, right? It just becomes to the point where you just keep messing with integer values until they match, and you can't read the tests and quickly see what's going on. So how about we make ourselves the life a little easier and create a helper type, annotated text. And so the idea here is that imagine I can do this. Imagine I could say, well, here's some text, right? Here's like, some code I want to write. Let's say, what is it? Var x equals 100. And then I want to say, actually, let's say let x equals 100. Then I want to say x equals 10, right? And then I want to assert that I get an assignment error here that x is a read-only variable, so you're not supposed to assign to that. And I want to assert that this is the actual position, or this is the actual span where the error is on. So imagine I can just put brackets around that, and then we know that this is the location where we expect the error. And of course, you may expect multiple errors. So let's say you may have multiple warnings or whatever, and you want to be able to put multiple of those all over your text, right? So basically, we want to have this helper type where we can express that somehow. So what would that look like? Well, clearly, yeah. It's already off to a good start with me typing all over the place. So of course we need the actual text, and we want to have an immutable array of, let's say, text spans. That is basically the thing I want to construct, if you will, right? So let's do this, and let's say public static annotated text parse string text. So the first thing is, if you declare things in C#, like I want to be able to write these things like this. Yeah, here's a hint. If you're not an English speaker, don't install another keyboard. It completely messes away with your muscle memory. Right, so I want to put these things somewhere in the string variable. So if you now look at the string, well, first of all, there's an initial line break here, and then there is all these redundant, indentations. I mean, it's not a biggie, right? Our lexer is kind of supposed to handle those things, but imagine your test breaks and you expect the text value in the debugger. You really don't want to see, this string here. What you really want to see is, right, basically you cannot do rectangular selections here, but basically the selection you want to have is this one here, right? But you basically just have, the indentation removed to this one. So one of the first methods we want to write ourselves is basically an unindenter, right? That basically, given the text, unindent, I guess. Yep, and I switched my keyboard again because why not? Text. And so let's just create ourselves a little string reader. New string reader text. Of course, you put this thing into a using. And then we say, what do we need? String line. And then we say while line equals string reader reads line is not null. I guess we need them somehow. Let's say we have lines that is in our case list of string is fine. We don't always have to use the immutable builders. Sometimes an ordinary list is just good enough. And then we say lines.add line. All right, now we have basically our lines. The other thing that I think I want to do now is determine the indentation I want to get rid of. So, right? So what is that? Is that I guess it's the minimum indent that we're looking at, right? And that would be in max value. And then we say for each var line in lines, we say indentation is line dot trim start dot length, right, line dot length minus the length without the indentation, right? And then we say min indentation is just math if only I could type. No, min, Jesus Christ, indentation. No, not an if statement. Min indentation and indentation. Congratulations, you write a line of code. Yeah, what's next? Now we have this guy. Now we want to trim everything. So we say for each var line in, no, in this case we don't want to do this. We want to say for var int I is less than lines.count. Today is not my day when it comes to typing. Clearly not. And then we just say lines I is lines I substring. And we start from the min indentation, right? So there's a few special cases here that we want to say. So if the line is completely blank, we don't care. So we want to say if line trim length is 0, then continue. You know what? I think I want to do this same pattern here. And then I just say var line equals lines I. So if the line is blank, then how about we just record the fact. And then I can say if lines I length is 0, then we say continue here as well. And then ultimately what we just say, we say return string dot join for our lines. And of course we want to do this with a new line. All right. Almost. I think the other thing I want to do is I want to remove all blank lines in the beginning. So I would say while list count, while lines count more than 0 and lines length is 0, we would say remove at 0. I do the same at the end. We would say, okay, well, we still have them. And lines count -1, remove at the end. Right, so this way we remove any blank lines at the end and any blank lines in the beginning. Great. So let's say text equals unindent text. Yeah. All right, now let's actually do this. For each var C in text. So we need to produce a result builder, right? So we need the, I guess, text builder equals new string builder. So we basically only go over all the characters and copy all the ones that are not markers. And then we just say, and of course we need our markers. So we say markers are, or I guess span builder. would be immutable array create builder text span. And then what we return is a new annotated text for text builder to string, and then a span builder to immutable. All right, if the current character is this, yeah, we have to somehow. So one thing that we probably want to support is we want to support nested spans as well, just for good measure. So how about we maintain a stack of start positions? So start stack equals new stack int, and then we say, well, var position equals 0. Then we say start stack push current position, else if C is closing, else we say position plus plus, and we say text builder append character, and then we say if start stack count 0, then something's really wrong, throw a new argument exception, name of text, and say too many in input or in text. Otherwise you say var start is start stack pop, end is position, so the span is text span from bounds start and end. We say span builder add span. We say now let's verify that our stack is actually empty. And same thing. Clearly we have I guess. All right. Yeah, 0 obviously not now. All right. That seems roughly right. But we will find out what happens when we actually use this guy. So let's make our life a little bit easier. Have a private void assert has diagnostics string text string diagnostics. Yeah, I guess before we do that, let me just sketch roughly what I'm expecting to see here. So private, actually public void let's say variable declaration reports redeclaration, let's say, right? So what would that look like? So we say our text equals this guy, and we say, if I say var x equals 10, and then I say var y equals 100, and then I say var x equals 10, that's fine. If I say no, var x equals 5, we expect to get an error here that X is already declared. And then we can say diagnostics. Well, what do we expect? Well, variable X is already declared. So we would say var annotated text is annotated text parse text. Then we can say var syntax tree is syntax tree parse for our annotated text text. And then we can say var compilation is new compilation for the syntax tree. And then we can say, what is a compilation? Evaluate new whatever, because we don't care, var result. And so, yeah, we need to basically now, same thing here, but for the diagnostics, we want to basically split it by line unindented. So I think what I want to do is I want to make this guy public. No, I want to have, yeah, I want to add another method, almost like this one here. We just say unindent lines. That one is actually public. And then I can say, I can just reuse this guy from here. And then hopefully this makes some sense. So what I can now say, all right, what are the diagnostics that I expect? Var diagnostic, I guess we should call this diagnostic text. And then we can say diagnostics is annotated text, unindent lines for our diagnostic text. And now there's a few things I need to validate. Of course, you want to make sure that, so if annotated text spans length is not the same as, yeah, let's just say this returns a string array, just for good measure. It's not the same as diagnostics dot length, then that means something is really wrong with the test definition. We can say throw new exception. We would just say error must mark as many spans as there are expected diagnostics. And then we basically just say, well, let's say var, yeah, for each, how do we do this? I guess we can just say var I equals 0, I is less than diagnostics length, I plus plus, var expected span is annotated text, spans I, var actual span is annotated text, is result diagnostics I span. And we can say the same thing here. We can say expected message, which is basically diagnostics I just call this expected diagnostics. expected diagnostics. And then actual message is a result. Yeah, I was almost there. Almost there. Diagnostics I message. And then we can say assert equal for expected message, actual message. And then we can say, how about we say expected span, actual span. Of course, now it would also be nice if you would assert that the number of diagnostics are the same. So equal, so expected diagnostics length with result diagnostics dot length. All right, so that thing looks somewhat sane. Well, let's see what happens. So we say assert text for diagnostics. So let's just call this assert diagnostics. Now let's see what's happening if I build this guy. Interesting. Oh yeah, of course, of course. We don't support multiple top-level statements. So if you want to have multiple top-level statements, then you have to put them in a block. See, this is nice. It's almost there. Put a period here. Nice. And so now, for us, adding more tests for diagnostics is now branded simple, right? You just have to do, here's the thing I want to run. You mark all the areas where you want diagnostics to occur, and then all you have to do is effectively just put matching entries here, and just say what you expect the error message to be for this particular area. So if you just go to our binder, and we just search for report, here's all the cases you would probably say. Okay, this is the first case we had, redeclaration, name expression, undefined variable. All right, let's do this. Let's call this variable, what is that, name expression. Name reports undefined. So we can just say x plus 10, right? In our case, that is super easy. You can make this even lower and say variable x is not declared. Is that the text? Is I have no idea actually. What do we say? Variable doesn't exist. Okay, fine. Doesn't exist. Of course, I closed the binder again for no reason. Okay, this is undefined. Okay, assignment, same thing. We want to check that. Let's call this assignment. That would be x equals 10. And then we probably want to say cannot assign, so let's check that. So let's say we have let x equals 10, and then we say x equals 0. Right, and now we would expect to say variable x cannot be assigned to, and that would be cannot assign. And then we also say cannot convert, right? So let's say we have, you know, var x equals 10, and then we say x equals true, in which case variable, or was it, cannot convert type boolean to in32, something like that. Let's see what happens with these guys. Okay, fine. Is read only and cannot be assigned, so is read only and cannot be assigned to. Oh yeah, that is super helpful. So let's fix that. Let's make sure our text span actually has a meaningful toString, so we can actually see what's going on here. Override string toString, and then we can say this is what do we say? It is start end. Seems to be useful. Yeah, we could implement iEquatable. Like, it's not, I mean, we get an auto-implemented version of that, which is not horrible. So we set expected 23 to 24, actual 25 to 26. 4 cannot assign. Yes, because we mark the assignment operator, not the variable name. Nice. And let's go back to our binder. Okay, we tested that, tested that, tested that, tested that. Yeah, let's test the operator as well. We added 2, because why not? Let's call this unary. Reports undefined operator. Well, I guess undefined is fine. So we say, how about we say plus true, right? In which case we would expect operator plus is not defined for system boolean, or something like that. Pretty sure the error message is not right. And then we say true plus, let's say 10 plus false. Operator plus is not defined for types system in 32. And let's vary things a little bit. That's great. Okay, it's unary operator. Okay, fine. And then the binary reports undefined error must mark as many spans as there are expected diagnostics. Binary operator. Okay, could have fixed that. Well, 4 type. So the downside is if you ever rename your error messages, you have to change a lot of text potentially, but those things are kind of find and false exercises. And to me, it's much more important that these things are, actually, these are things where I honestly think we should change our diagnostic bag. Because everywhere else you put things in quote. Yeah, let's do that. Sweet. And yeah, I find those test cases actually fairly easy to read now, and like they're as minimal as it gets, right? I mean, there's not a single redundant line in those test cases because you need to somehow express what you want to test, what your expected outcome is, and then the do it method, right? It doesn't get any shorter than that. So I think I'm somewhat happy with that. Now for consistency, let's just extract the method here and call this assert value, which is basically the positive case, right? All right, I think I'm happy with what I have here. Any questions? What I have done, why I've done it? Now is your chance. Annotated text, bunch of test cases, fix those. Actually, let me do those first. Make error message is consistent. Not sure unindenting is a word, but I go with that for now. Yeah, this is where it gets a little bit tricky with I guess that actually does work, right? Does that compile? It does. Extract sort method. This is what happens when you try to form a commit that is somewhat sensible. Next conflict. There is none. Right. Because what? No, it's not the fun we want, right? Here we go. Blah, 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 blah. Yeah. All right. Let's call this commit add tests for diagnostics. And this is now just the merge file, right? Yeah. God, I wish I wouldn't have to delete them all the time. I know there's a setting for that, but I keep moving between machines and then I have to reset the setting every single time. All right, let's just push the branch now. Push U. Nope, not that one. This one. Alrighty, so I think I've done basically what I wanted to in terms of errors. Yeah, so I think his name is Jimmy or Jim is asking whether we should have an error code rather than testing the messages. That is a good point. We could do that. Now the tricky thing is you often want to also make sure that the content of the error message is actually applicable to the location too. So you want to kind of assert that you actually reported for variable X and you don't mess it up elsewhere. The way you could do this though is similar to what Rosin has done, is that their diagnostic instance basically has an error code plus basically they store the params the way that you would normally just pass to the message formatting. And then you can just assert those. That's also workable. I don't know, man. On the other hand though, like how often do you change your messages? Not that often, right? And I honestly like the idea that I can just read the error messages in my text and just have that work. What I have also done in the past is when you write these tests, so when I add an error code, let's say eventually we will want to have error codes as well, so that consumers of diagnostics don't have to do string processing. And then you would just do something like this, right? You would say, MC 12 colon, and then you would just, when you parse the diagnostics on the other end, you would just extract those guys into the error code and then assert the enum value there as well, right? But I don't know, just using the error code does not seem right because you still want to assert that those things here are correct as well, right? All right, so now let's talk about conditional operators. So one thing we haven't done is, if I remind ourselves, if we go to our Lexer, where is it? Obviously, it's in syntax. So what I want to add now are these operators. I want to add less than or equals to, greater, equals to, and greater. So let's find them. Probably they should go here. Seems reasonable. Here's our equality. So let's say we have case. And we have this case. So position plus plus. Actually, here's where copy and paste is actually working in your advantage. So this would be less token, and this would be less or equals token. Is that right? Yeah, that looks right. And then we do, this would be greater token, and this would be greater or equals token. So let's add these guys. Actually, let's fix the typo in this guy. Here are our tokens. Let's move them where they belong. So we have here our equals. They should go here, I think. Syntax facts. So you have to put them here in the right thing as well. So what do we have here? This is these guys. Bum, bum, bum. So what do we have? We have less token. We have the less or equals token. We have the greater token, and we have the greater or equals token. So that would be this one. That would be less equals, and that would be that one, right? Seems sensible. And of course, we don't have to add this to the binary operator precedence as well. So where would we put them? I'd say they're the same priority as the equality ones, because I don't see a reason why they would bind stronger. Okay. Now, we also have to add them to our operator table, so we know about these guys. So let's go to binary operator, and let's define these guys. So they are similar to these, right? So we have the less token. That would be less than. It's defined on int and returns a bool. Less or equals less than or equals to. You know what? Consistency is a thing, right? Why would we name them differently? That makes no sense. And then we do the same here for these guys. You just call them greater. All right, so we now need these operators. So let's go here. What is that? Less equals. Yeah, they're also in the right area. Perfect. They belong to ints. What is cool is that we didn't have to change the parser. I just want to point this out. That's the nice thing with being data-driven. Now let's go to our evaluator, and of course we're now in the binary case. We have to now add a few more conditions here. So that would be less, in which case we would do effectively this. And rinse and repeat. So less or equals, greater, greater or equals. All right, so let's add tests for that guy. Where will we put them? Probably somewhere here, right? So 3 is less than 4, true. 5 is not less than 4. I'm sorry, what is it? Right, so this is this side, and then I guess we can just cheat and say, let's just reverse the sides. So this would be 5, 4, 4, 5, 3, and this would be 4, 4, 4, 5, 4. Let's see what happens. Yes, so that's a good one, right? So we have these token pair tests that says that you can parse certain tokens after each other. And of course, if we now have an equal less token followed by an equals token, we no longer parse them as separate tokens. Or not no longer, we never parse them. But now, clearly we have to say in our Lexer tests here that those combinations will not work. So if this is a less token and this is an equals token, or it's an equals token, then you can't parse them directly, right? So same for the greater token. Greater, wait, oh. That should fix at least a few of them, if not all of them. Nice. All right, so I think that seems reasonable. So let's delete this blank line here, this blank line here, and this blank line here, because they don't actually add anything. Sweet. Add support for less. Perfect. So, yeah, let's skip the bitwise operations because they're not that interesting. Let's actually do the fun part now, given that I'm already an hour in. It's time to do some of the cool stuff. So, what we now want to parse is if statements. So let's go to our statement syntax here. Let's add a new derived one. Public sealed class if statement syntax, which is a statement syntax. What do we take? Well, a few things. We take a syntax token, the if keyword. We take an expression syntax, which is the condition. And we take a statement syntax, which is the then statement. Right? Now, of course, we also want to be able to express an else. So what we could do, which is pretty bad, what we could do is we could say, well, there is a syntax token here, syntax token, else keyword, and then statement syntax, else statement. But what I don't like about them is that, they're either both present or they're both null, right? You cannot have this one null and then this one present, or this one present and this one null, right? Like, these combinations make no sense. To express it a little better, what I would do is I would say, well, let's add a new node, public sealed class, and we call this the else clause syntax. And that's just directly deriving from syntax node, right? Because that it's not a valid statement in itself. It's just data effectively for our if statement, right? So we just do that, and we just put these guys in here. And now this is becoming really easy. We can just say there's now an else clause syntax, else clause, and this one is either present or it's not, right? And in this case, if you construct this, you need to both provide them, right? So that makes it a little easier to reason about what is actually valid. Now we say, okay, let's say this is syntax kind, what is it, if statement. Let's move this guy here. Let's see where this guy ended up. Nope, definitely don't want to have it there. And then we say same thing here. We need a syntax kind for this, and we say this is syntax kind else clause. And this is just a generic node, right? That goes back to this section. And yes, this is syntax, obviously. And then we record these guys. All right, let's put these guys into separate files. Now we need to modify our parser so that we can actually parse it. What happened here? Where the studio code syntax highlighting is broken? Interesting. Well, before we do that, let me actually go to my syntax facts, because we now need to introduce the keywords. Syntax facts, where are you? So we need an if keyword, which belongs here, I think. If, let me say if keyword, if keyword. We need an else keyword. Else. And of course, we have to do the same thing in the reverse side. So the else keyword is else, and this guy here, the if keyword is if. So now that I have them, I can say, well, if there is an if keyword here, then we say parse if statement. pass variable here. So we say var keyword equals match token syntax kind if keyword var condition equals parse expression var statement equals parse statement var else clause is parse optional else clause. Yeah. Return new if statement syntax for keyword for condition for the statement for the else clause. All right. This is the else clause syntax. So if current kind is not syntax kind else keyword, then we don't have one, so we return null. Otherwise, we say var keyword equals next token, and then we say var statement equals parse statement, and then we say return new else clause syntax for the keyword and the statement. Yeah, and it's it doesn't get better here. Okay. Seems straightforward. Now let's bind this guy. So this would be a statement, right? So we go here and we add it before this guy. And we say this is an if statement. In that case, we say bind if statement for an if statement syntax. Bind block statement, bind variable declaration. Yep. So var condition equals bind expression for for syntax condition. So what do we want to validate here? So we want to obviously validate that the condition is resolving into a type called bool, right? So one way to do this is we can just add a new method here where we centralize this, because you will have this in multiple places. So we will add another method here, bind expression, where I can also pass in the type target type. And now I can say var result equals bind expression for syntax. And then I can say if result, region. No. It's not the target type. Then we just say diagnostics report cannot convert. That would be syntax.span. From type is result.type, and the target type is target type. I say return result. Right. So this way we know that this is now of type bool. Var statement. We say bind statement, right, for syntax then statement. Let's call this the then statement. And then the else statement is, so if syntax else clause is null, then it's null. Otherwise, it's bind statement for syntax else clause else statement. And then we say return new bound if statement for the condition, for the then statement, and for the else statement. Right? Interesting. Probably forgot to move this guy into a separate file. Internal sealed class. Bound if statement is a bound statement. As I said, what do we take? We take a bound expression condition, a bound statement, then statement, and we take a bound statement, else statement. Oops. Yep, and we need a bound node kind if statement. That goes here. Let's move this to a separate file. Sweet, now we actually have it bound. And now let's interpret this. Where is this guy here? If statement, and then we say evaluate if statement for the bound if statement. And we would say if bool, I guess var condition is bool, evaluate expression for a node condition, and then we say if condition, then we say evaluate statement for a node statement, else if node else statement is not null, then run the else statement. All right, let's see whether this actually worked by adding a test for that. Now we get a little bit hairy here. I think at some point we should probably break this up. If a is 0, then a is 10, and then the result should be a. So the result should be 10. Oh my god, that just worked. That's ridiculous. If it is 20, so if it is 5, that should work. And you want to do the same thing with else. If, so let's have both of them here. Else a is 5, else a is 5. In this case, it should be 5. So I want to basically test both cases where I have an if with an else and if without an else. I want to make sure that regardless of which path I take, nothing bad happens. And that seemed to work. Now, let's just do another thing. Because what's quite interesting is also, like, else is this well-known, there's a well-known phenomenon in parsing. Let's just quickly talk about this. So, let me first say show tree, and say var a is 0, right? And then we say if a equals 0, else yeah, actually, what just happened there? Let me think about how I want to do this. So var x equals 0 if x is 0, and start a block. And then we say if x it's nonsensical, but that is not the point right now. Yeah. So what's interesting here is the question is, if you look at the syntax here, right? The question is, where does this else belong, right? We can either say this else belongs to this if, or we could say this else belongs to this if, right? The reason the way it's written right now is like it's unambiguous because this one has a block marker. So clearly this entire thing here is nested under this if. But if I leave these markers off, it gets ambiguous, right? Or logically at least ambiguous. So let's see what our parser actually does. So we say var x equals 0. We don't even need that. We can just say if 5 is less than if 4 is less than 5. 5. Now what do we want? Oh, sorry, I'm an idiot. Oh, interesting. What happened here? Notice now. Oh yeah, our pretty printer doesn't handle the fact that things are null. If child is not null, return child. If child is not null, return child. I guess it's the first time we had an optional an optional construct in our tree, show tree. So one more time. So if 5 is less than 10, if 5 is also less than 15, 10, else 20, right? So that looks reasonable, except that this else here is not belonging to this if. Right? You can see this in the tree because the else here is under the second if, right? And this problem is also referred to as the dangling if problem, the dangling else problem in parsing. And most languages solve it the way that our parser handles that as well, is that it's just the else gets associated with the nearest if, right? And there's various ways you can solve this in your language. You can either require that, if doesn't have arbitrary statements, it only allows blocks, so you always have to put braces, which many people do for coding style anyway. Or you can basically just have a language like Python where blocks don't exist in terms of tokens, they just exist in terms of indentation. When people indent it like this, it's the same as putting braces in the right spots. Or you can do other things like, disallowing certain things in certain contexts, like disallowing like if to be direct, nested member of if. So if you want to do this, you have to put braces. There's various ways. All right, so then I think this was it for what's happening here. For the if statements so far. So let's add these guys. So parsing if, besides the keywords, no, actually that is one we should do separately. In fact, Let's try this one more time. Let's first do these. Git commit fix bug where pretty printing fails with null. All right, and then we just add this guy here. Dum, 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 dum. Add support for if statements. All right, so that was easy. Only have 40 minutes left. I can't believe it. All right, so let's talk about while statements now. So same thing. We will start the same way. Let's start with our lexer. In fact, let's start with syntax facts, because the only thing we have to do is add a new keyword. So we have the while keyword now. So let's put this guy in the right spot. Nope, that's not the right spot. That is the right spot. And then I have to say, if the text is while, it's a while keyword. All right, now we can lex it. Now let's parse it. Same thing here. So let's say while keyword. In that case, we say parse while statement. So var keyword equals match token syntax token kind while keyword, and then we say condition equals parse expression, and then we say parse statement, and then we can just return new while statement syntax for keyword, condition, and body. So let's add this guy. Public sealed class statement syntax. One statement syntax. What do we take? We take a syntax token while keyword. We take an expression syntax condition, and we take a statement syntax body. Syntax kind while statement. Move this guy into its own file. All right. Now let's actually add the bound while statement as well. So internal sealed class bound while statement is a bound statement, and it takes while statement. It takes a bound expression condition, and it takes a bound statement body. Right? We implement this guy and say bound node kind is, what is it? It's a while statement. Same concept here. Put it there. And then when we're binding it, let's go to the binder. If statement, we say while statement, while statement, and then we say while statement syntax, bind while statement. Almost the same thing here. We bind the condition to type bool, and then we say body is obviously body, and then we can say return new bound while statement for condition and body. So far so good. And now let's go to the evaluator again, and same thing happens here. So let's say if we have a bound node kind while statement, all we have to do is evaluate while statement, bound while statement, and all we now do is to say while bool node condition, evaluate, obviously evaluate expression for condition, evaluate statement for node statement. Right? Not that hard. So let's say we have a variable I. We say while 10 var result 0, while I is bigger than 0, we say result equals result plus I, and we say I equals I minus 1. And then we expect the result to be the sum from everything to 10, which might not be that easy. So let's just say 0 and see what ends up happening when we run this, because I suck at math. Let me just Google the answer. Sum first 10 numbers. Really? 55, apparently. And the tests are passing. That's not right. Oh, that's because we don't actually select the result. We should say result. Yeah, 55. All right, that sounds right. Right, obviously the code that I'm writing here is not the code that you would write normally, right? This is also a great example why most languages actually require a semicolon, because this is borderline unreadable, right? You would, if you want to read this in a single line, you really want to put some semicolons in there. But our language doesn't have semicolons, but we should probably eventually disallow things like this, where you just put everything on one giant line and code becomes effectively unreadable. But not yet. All right, so we have a test for that guy. All right, git commit add support for while statements. I have a bug in my commit message. Let me check that. Yep. Okay, let me revert this guy. Fix bug where pretty printing fails with nodes. All right. Here we go. Thanks, guy. All right, so we have those. Now let's talk about for statements. For statements are a little bit more interesting. I mean, basically, we just used while to do, basically for statements. But of course, we want to have a decent support for that. So again, let's go to syntax facts. We will need a for keyword, which would be here, for keyword. And this would go here. And then same thing here for the for keyword. We do that. Now let's actually check what this thing would look like. So public sealed class for statement syntax, statement syntax. So I'm shooting for something simple like this. For I equals 1 to 10, do something. So that would mean we do, we take a syntax token, identifier. We take a syntax token equals token. We take an expression syntax lower bound, and we take an expression syntax, upper bound. And then I just decided that they're inclusive. Yes, you will not like that, I know, but it's fine. It's fine. Bound node kind, syntax kind for statement. So we move this guy here. For statement, generate. Yep. Now let's go to the parser. Same thing here. So if you see a for keyword, then we say parse for statement. So we say var keyword match token syntax kind identifier, right? So no, syntax kind for keyword identifier is match token syntax kind identifier token. We say equals token var lower bound parse expression. Upper bound is parse expression, and then of course we need a body parse statement, and then we say return new for statement keyword identifier equals, no, not that one, equals token, and lower bound upper bound, and it looks like I forgot the body. So let's fix that. I need the statement syntax for the actual loop body. What? Identifier equals token. Oh, you're right. Needed a syntax token, keyword. There we go. All right. We parsed it. Now let's bind it. So same concept here. We just say while. Now we say for statement. Well, let's bind a for statement. So in this case, we want a lower bound, which is bind expression for syntax dot lower bound, but we want the target type of type int, otherwise bad things will happen. Same we do in upper bound. And of course, name is syntax dot, what is it, identifier dot text. We needed a variable for this guy. Var variable is new variable symbol, name. It is read-only, and it is of type int. Then we can say scope is new bound scope for our current scope. And we say scope is scope.parent at the end. Yeah, this is practically impossible because we just created a new scope. So clearly, this is the only variable in that scope. And since we support shadowing, this error can never occur. But let's leave it in for now because it doesn't really matter. And then we say var body equals bind statement for our syntax body. Right, and then we can say return new bound for statement. We'll probably include the variable. We probably want to include the lower bound, the upper bound, and the body. All right, so now let's check this out. So this would be internal sealed class bound for statement. It's a statement. It's a bound statement. Sure. What is a bound node kind for statement? Let's put this guy also where it belongs. And now we say, well, what do we take? We take a variable symbol, which is the variable. We take a bound expression, which is the lower bound. We take a bound expression, which is the upper bound. And we take a bound statement, which is the body. Oopsie daisy. Does that make sense? I think it does. All right. That seems sane. All right, now let's go to our evaluator again and make sure we do that as well here. So then we encounter a for statement. We say bound for statement, right? And evaluate for statement. Boom, 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 boom. So variables node variable is evaluate expression for node lower bound, right? Then we say, so long our yeah, actually, we can actually make our lives easier. We can say lower bound equals int this guy, right? And then we can do the same thing here. We can say upper bound. And then we can just say for var I equals lower bound, I is less than or equal to upper bound, I plus plus, I, and then I can say evaluate statement for node body. Yeah, which we probably should have recorded. Apparently we did not include the body in our bound node. That is not good. There we go. Yep, Jimmy is correct. All right, so, oh, you're absolutely right. David, you're absolutely right. Yeah, there's no to. That is correct. It actually fixes in the parser. So first of all, we would need another keyword here, which would be here probably. So that would be the to keyword. All right. Let's put this guy also where it belongs. That would be probably here, right? And then we say if it's to, it's the to keyword. And then same thing here. We have our equals token, lower bound. Let me say syntax token to keyword. Yep, that's where it belongs. Now our parser needs updating. So we say var to keyword is match token syntax kind to keyword, and then just pass that guy in to keyword. There we go. Well, let's check out what happens. Var result is 0. We say for I equals 1 to 10. Result equals result plus I. So it's same as before. We sum up the first 10 numbers, so that should be 52. Expected 55, actual 1. Okay. That is interesting. I don't expect that to fail. I bet you that what's happening is that somewhere I did not pass in the right values, probably in the binder. I probably assigned the lower bound to the upper bound without knowing the details, but that seems like a likely mistake. Yeah, we did not bind the upper bound, we did bind the lower bound, which is obviously not helpful. Nice. All right, so one thing we want to make sure, actually I was a bad boy. I did not add the test where I should have added the tests, but we can do this now because testing is fun if you do it the right way. So, assignment, yeah, let's go here. Let's call this, what did we say? If statement reports. So if we say something like if 10 var x is 0, x is 10. So we expect this to be cannot convert system in 32 to system boolean. All right. We would expect the same thing for, what is this, while statement. So we say while and then of course for statement, same thing, cannot convert lower bound. So we say var, let's say result equals 0, and then we say for I equals false to 10, result equals result plus I, cannot convert boolean to system in 32. And we say upper bound 1, 2, true. And of course I have to mark them. Let's see what ends up happening here. All right, that is nice. That this actually worked. So let me, where are my tests? Where are my tests? Okay, if statement, let's add so what do we have now? We have this guy. No, I don't want to stage this one. But I think we want to stage these guys, right? Probably not that. Actually, no, we want to stage this one. What am I talking about? Yes. All right. Crafting the perfect commit. Add error tests for while, for if and while statements. Yep, that looks basically what I want. That all adds up. For statement. All right, so git commit, add support for statements. So the thing that I'm actually trying to make this somewhat readable. I think I want to rename some of the test cases here to create some level of consistency here. Okay, let's call this unary expression. For statement, what statement, if statement. Okay, assignment, expression, right? Let me call this name expression. All right, let's take all of those expressions, move them down. So we have variable declaration, which is a statement, if statement, while for. Okay. Now let's take a look at those guys. Pretty sure we have those guys before these guys. Let's just look at syntax kind. What do we have? We have literal, name, unary, binary. Really, name is before everything else? I guess it is what it is. All right. Name, unary, binary, parenthesized and then an assignment. Okay. Good enough. Yeah, I'm not going to review this like this because it's going to be a tragedy of a div. Git commit, reorder, and rename. Reorganize evaluation tests. All right. So I think that is pretty much it. Any questions, comments, suggestions? Oh yeah, the one thing that we may want to look at in the last minutes is our infinite loop problem. So quick reminder what's happening here. If we go to our evaluator, let's maybe try to write a test case for that. Block statement, no infinite loop. So this today will cause an infinite loop. Expected statement, but found. And yeah, I think there's something else, unexpected token or something that we should have here. Unexpected token. Yeah, it's the other way around, right? We want, this is causing infinite loop. So right now, if I run this guy will time out because it will run an infinite loop. Like, I don't know whether does Extend actually time out or does it just run forever? Regardless, let's keep this guy running. So what the problem is this, right? In our parser, when we say parse block expression, where is it? We say, well, keep going until you either see an enter file or a close brace token. And then we say parse statement, right? And then parse statement says, great, let's try to parse a statement. So I don't have any of those guys, so it goes down to parse expression statement. It says parse expressions. It goes to all of these guys here, it goes all the way to the bottom, ends up in parse primary, where it then says, well, what do we have? Open parenthesis, no, false, true, no, number, no. Okay, then I expect an identifier token. So it goes in here, matches the closing parenthesis, says, okay, that's not it, and then produces a new synthesized token, and then goes all the way back up, and then we are in this part of our loop again. Where is it? We go in the loop around, and we're still standing on the closing parenthesis. So we keep standing on the closing parenthesis. We never advance anything. So one way to solve this problem is to say it's like start token is current, and then we can say, well, if start token, actually, no, let's not do that. Let's say start token is current. And then we say, yeah, if the current token is still the same token I started with, then basically we have to eat the token. And you basically have to say, okay, something bad happened. Now, I'm not sure I just want to eat the token because that can result in a gazillion errors, right? If you have one error somewhere, you have an additional closing brace now, a closing thing, I will know. Actually, okay. If parse statement, I guess this is the way we do it. If parse statement did not consume any tokens, let's skip the current token and continue. An error, we do not need to report an error because we already tried to parse an expression statement. I'll just say we need to skip the current token in order to avoid an infinite loop. We don't need to report an error because we already tried to parse an expression statement and reported one. Yeah, so this guy is going forever. But now it should no longer do that. Well, famous last words. I guess you have to kill .NET by hand now. What is happening now? Oh yeah, okay, that's a different error that we can also fix actually right now, because it annoyed me many times before. So let's first fix this and say git istage and say, well, actually that's not, because the we're not quite there yet. So let's actually do this. Let's actually say git stash. Let's first fix the other bug, and then we come back to this one here. So basically, another bug that we have currently is, where is this name expression? Name expression, name expression. No skipped. No reports. No error for inserted token. So if we say a blank input, we expect some sort of error. I don't know what it is. But today, if I run this, it will go down the parse expression statement. It will insert a name expression and then crash because our binder, when we bind a name expression, we try to look up the name, and the name is null because the token was inserted. So if string is null or empty, then we just do this for now. This means the token was inserted by the parser. We already reported an error, so we can just return an error expression. So we don't have error expressions right now. This is the other thing we need to add eventually to avoid cascading errors. But in our case, we just return a bounded literal expression and then move on. Which now means if I run this guy, what? Oh, yeah. You actually have to pass in the value, as it turns out. Yeah, so of course we expect an error. It's like, what does it say? Something like expected identifier but found end of file or something to that extent. I don't know what the actual error message is. So let's just add something and then just see what the actual message ends up being. What? That's a good point, actually. Let's try this. Unexpected token, expected. Expected identifier. Something like that, I suppose. close enough. What are you talking about? Identifier token. That looks exactly the same to me. Oh, we had an extra space, as usual. Fine. Okay, now we can say ensure binder doesn't crash when binding inserted identifiers. I should say when binding synthesized, fabricated, whatever, fabricated identifiers. All right, now let's say git stash pop. Of course we have, no, actually we don't have conflicts. Great. So now when I build this guy, I should just really? What are the errors? What would it be? Probably we expect 2 errors, as it seems. Expected 1, actual 2. Evaluator block statement, no infinite loop. Expected 2, actual 1. Oh, because yeah, I'm an idiot. I am an idiot. I inserted it in the wrong area. Where's our infinite loop problem? Infinite. Here we go. I guess there's one more. I don't know what the actual. This is one of those problems when you don't know actually what the outcome is. Maybe I should just change the assert to output exactly what we expect. So unexpected token, expected. Okay, that's the first thing. We can do that. Expected identifier token. All right, we know that already. So let's run this guy. And then we say, yeah, unexpected token, enter file, expected. Oh yeah, exactly. So of course we now have another one for the closing brace. Expected okay, fine. I think we need to fix the error message here eventually. Close brace token. But at least we don't crash, and at least we don't run into an infinite loop. All right, so we have this one, block statement, no infinite loop. Fixed, fix bug, and ensure parser doesn't loop infinitely on malformed block. Alrighty. Yeah, I think that's it for today. So what we did today is we added support for conditional operators, less than, greater than, all of that. We added if statements, for statements, and while statements. So now we have at least the bare bones minimum of what you would need in statements to actually do something, semi-useful. Next week, what I want to do is I want to prepare ourselves a little bit more for actually executing thing in some sane fashion. So right now, our evaluator is basically just walking the exact syntax, and we call methods for everything. What I really want to do next week is start lowering those to basically go-tos, right? Because all control statements, all control flow statements are basically just go-tos under the covers, which includes if statements and all the other ones as well. So we'll introduce a concept of lowering, where we basically write our boundary to something simpler, and so that we can emit IL eventually, right? Or assembly code, or whatever we want to do. All right, so I hope you enjoyed the current episode, and I hope I see you next week. So far, bye-bye.